Hi, I'm Mike Schnecker, Business Development Manager at Rohde & Schwarz, and here we have the new Rohde & Schwarz MX-05 oscilloscope. Now, this particular model is an 8-channel version, and what we're going to show is how you can use the very high channel count, which includes 8 channels and 16 digital channels, to analyze a very important circuit for power delivery, something called a multi-phase buck converter. So we have a setup here with a 10-phase buck converter. It's capable of delivering 300 amps into a voltage of 800 millivolts. And we're probing all of the relevant signals here. So we've got a probe on the voltage output of the power supply. We're measuring the current output of the power supply as well. We have a probe monitoring the switch node of the primary converter, and we've got logic channels probing the switching nodes of 7 of the other converters. So on the screen we're showing the relevant signals here. This is a load step response test, so we're injecting a load using the built-in arbitrary waveform generator on the scope. The step switches a transistor with a very small resistive load, and on the trace here in the top left you can see the blue trace is the current coming out of the power supply. It goes from 0 up to 133 amps. It's a 10 microsecond wide step. And we're observing the voltage out, the green trace, and you can see how the voltage dips after the step and then recovers and then settles out. That's typical response you'd want to see in a converter, not too much voltage change. And we have a couple of other measurements that we're doing at the same time. We're looking at the input voltage to the converter, that's the yellow trace. We're looking at the input current, which is the bluish trace here. And then we've got on the right 2 spectrums, the input and output switching spectrums. So we're always interested in that for EMI purposes and for noise. We always want to see what components are there. And down on bottom we have all of the switching nodes displayed at the same time. So we're actually looking at the pulse width modulation of 7 of the nodes probed with the logic channels plus the 1 main node probed with an analog channel. And if you can look back, you can sort of see how the pulses are about the same width, but they widen out right here. That's during the load step. What happens is the switchers turn on for a longer period of time to recover current that's lost during the load step. And then after the load step is gone, they all switch off for a moment just to allow so that no overshoot happens on the voltage. So this is how you'd expect it to work, but you can validate this using these connections. So another interesting display here, and this is actually a plot of the pulse width of 3 of the phases as a function of time. And so here, right in the middle, that's when the load step occurs, and you can see how the pulse widths are constantly narrow, and then all of a sudden they get wide during the load step, and then they go back to normal and settle out. So you're actually able to see in real time the response of this converter to a very large load step and validate that both the voltage and current remain constant throughout the process, and also to validate the control of the buck converters, making sure that your controller is doing what you'd expect it to do. For more information on the MX-05 oscilloscope and this type of measurement, please visit us at our website, www.rohde-schwarz.com, and thanks for watching.